Inside every cell, thousands of energy-producing reactions are happening every second to keep the body functioning properly. One of the key molecules involved in those processes is NAD. NAD acts like a cellular helper that allows mitochondria to efficiently convert nutrients into usable energy while also supporting many of the body's repair and stress response systems. It's especially important during times of physical stress, aging, inflammation, and increased metabolic demand, because many protective pathways inside the cell rely on adequate NAD availability. Over time, however, NAD levels naturally tend to decline. As that happens, cells often become less efficient at producing energy, responding to damage, and maintaining normal function. Researchers now view this decline as one of the major contributors to reduced cellular resilience and age-related dysfunction. In this chapter, we'll explore how NAD works inside the body, why it has become such an important focus in longevity research, and what may help support healthy NAD function over time. Every cell in the body requires a constant supply of energy to perform its daily functions, from repairing tissue and supporting the brain to maintaining metabolism and protecting against stress. One of the molecules that helps make all of that possible is NAD. NAD is present throughout the body and serves as a critical participant in many of the biochemical reactions that keep cells functioning properly. Inside the mitochondria, it helps shuttle electrons during energy production, allowing nutrients from food to be converted into usable cellular energy. Beyond metabolism, NAD is also heavily involved in cellular maintenance and stress response pathways, especially those related to DNA protection and repair. What makes NAD particularly important in longevity research is the fact that its levels tend to decline over time. As that decline progresses, many cellular systems become less efficient at adapting to stress, maintaining energy output, and recovering from damage. Researchers now believe that reduced NAD availability may play a significant role in the aging process and in the gradual loss of cellular resilience that occurs with age. In many ways, NAD can be thought of as one of the foundational support molecules that helps cells continue functioning efficiently over the course of a lifetime. What makes NAD so important is that it influences multiple systems that cells rely on every day to survive and function efficiently. One of its best-known roles involves energy metabolism. Cells are constantly generating energy to support movement, repair, communication, detoxification, and countless other processes throughout the body. NAD helps facilitate many of the reactions required to keep that energy production running smoothly. But energy is only part of the story. Cells are also continuously exposed to stress from inflammation, toxins, oxidation, metabolic strain, and normal aging. To manage that stress, the body depends on sophisticated repair and maintenance systems, many of which rely heavily on adequate NAD availability. NAD also interacts closely with longevity-related pathways that help cells adapt, recover, and maintain stability over time. One reason this has become such an important area of research is because NAD levels tend to gradually decline with age. As that happens, the body may become less efficient at maintaining cellular performance and resilience under stress. Researchers now believe that this gradual reduction in NAD may contribute to many of the functional changes commonly associated with aging itself. So while NAD may appear to be a single molecule, its influence extends across energy production, cellular maintenance, stress adaptation, and long-term biological resilience. Every function in the body, from muscle contraction and brain activity to detoxification and tissue repair, requires a constant supply of cellular energy. That energy is generated primarily inside the mitochondria, often referred to as the power plants of the cell. Within those mitochondria, nutrients from food are broken down through a series of metabolic reactions that ultimately produce ADP, the molecule cells use as their primary energy source. NAD plays an essential role in that process by helping transport electrons through the energy production pathway. In many ways, It acts like a metabolic carrier that helps keep the entire system moving efficiently. When adequate NAD is available, cells are generally better equipped to maintain energy output and adapt to physical and metabolic demands. But as NAD levels decline, mitochondrial efficiency may begin to decrease as well. Over time, that reduction in cellular energy production can contribute to fatigue, reduced resilience, slower recovery, and impaired cellular performance. This is one reason NAD has become such an important focus in discussions surrounding metabolism, mitochondrial function, and healthy aging. Cells are constantly exposed to internal and external stressors throughout life. Oxidative stress, inflammation, environmental toxins, metabolic strain, and even normal daily metabolism can all place pressure on cellular structures over time. To remain healthy and functional, the body depends on highly coordinated repair and maintenance systems that continuously monitor and respond to cellular damage. NAD plays an important role in supporting many of those protective processes. Certain repair enzymes and stress response pathways rely heavily on adequate NAD availability in order to function efficiently, particularly those involved in maintaining DNA stability and cellular integrity. This becomes increasingly important as cells age and cumulative stress begins to build over time. When repair systems are functioning well, cells are generally better able to adapt, recover, and maintain resilience under physical and metabolic stress. However, declining NAD levels may reduce the efficiency of these maintenance pathways, potentially allowing damage to accumulate more rapidly over time. Researchers now view this relationship between NAD, repair capacity, and cellular resilience as one of the major reasons NAD has become such a significant focus in longevity and healthy aging research. In many ways, NAD helps support not only the energy demands of the cell, but also its long-term ability to maintain stability and function throughout the aging process. As NAD availability begins to decline, many cellular systems may gradually become less efficient at meeting the body's ongoing demands. One of the areas most affected is energy metabolism, since mitochondria rely heavily on NAD to help drive ADP production. Lower levels can contribute to reduced cellular energy output over time. When cells are producing less energy efficiently, the effects may eventually be reflected in overall vitality, recovery capacity, physical endurance, and metabolic resilience. Reduced NAD availability may also influence how effectively cells respond to stress and repair normal wear and tear. Every day, cells must constantly manage oxidative stress, inflammation, environmental exposures, and damage generated through normal metabolism. Under ideal conditions, the body's repair systems help maintain stability and function despite those stressors. But when cellular maintenance pathways become less efficient, damage may begin accumulating faster than the body can adequately repair it. Over time, this combination of reduced energy production and impaired repair capacity is believed to contribute to many of the functional changes associated with aging. Researchers now view declining NAD levels as one of several factors that may influence the gradual loss of cellular resilience seen over the course of aging and chronic stress exposure. In many ways, low NAD reflects a broader decline in the cell's ability to efficiently produce energy, recover from stress, and maintain long-term biological performance. Although NAD levels naturally tend to decline with age, research suggests there may be several ways to help support healthy NAD metabolism and cellular resilience over time. One area receiving significant attention involves NAD precursors, compounds the body can use as building blocks to help maintain NAD availability. Certain nutritional strategies and targeted supplementation approaches are being studied for their potential role in supporting these pathways. Physical activity also appears to play an important role. Exercise places controlled stress on the body, which can activate adaptive cellular responses related to metabolism, mitochondrial function, and energy efficiency. Periods of fasting or reduced caloric intake have likewise been associated with activation of several longevity-related pathways that may influence NAD production and cellular maintenance mechanisms. Sleep is another major factor. During deep restorative sleep, the body carries out many of its most important recovery and repair processes, including hormonal regulation, nervous system recovery, and cellular restoration. Beyond any single intervention, the broader goal is to create conditions that help cells remain metabolically flexible, energy efficient, and resilient under stress. Researchers increasingly believe that long-term lifestyle patterns, including movement, nutrition, recovery, sleep quality, and metabolic health, may collectively influence how effectively the body maintains healthy cellular function throughout aging. Throughout this chapter, we've seen that NAD is deeply connected to many of the systems that allow cells to function efficiently and remain resilient over time. From mitochondrial energy production to cellular maintenance and stress adaptation, NAD helps support processes that are fundamental to long-term cellular performance. Researchers continue to study how declining NAD levels may influence fatigue, recovery capacity, metabolic efficiency, and the broader aging process itself. What makes this topic especially important is that cellular health is not determined by any single pathway alone. Energy production, repair systems, inflammation control, metabolic flexibility, and stress resilience all work together as part of a highly interconnected network inside the body. NAD appears to sit near the center of many of those interactions. And while aging is inevitable, supporting the systems that help cells adapt and recover may play an important role in maintaining function, resilience, and quality of life over time. But cellular health depends on more than energy and repair alone. Cells must also communicate efficiently, receive oxygen and nutrients effectively, and maintain proper signaling throughout the body. And that brings us to another critically important molecule involved in circulation, vascular function, and cellular communication: nitric oxide. Nitric oxide plays a major role in blood vessel function, oxygen delivery, circulation, and cellular signaling, making it another key player in the science of energy, performance, and healthy aging. And if you'd like a simple guide that walks you through practical ways to support cellular energy, recovery, and long-term health, we've also created a free resource you can download using the link below.